to this problem, I started with the brute force. That's the first thing that came into my mind. But then I hit the TLE on some of the test cases. I did refer to the hint a little bit, and then I tried to optimize it by myself, but I kind of failed. So I did use some help. Okay, let's start solving for today. Let's see what we got today. LeetCode. Closest equal element queries. Okay, you are given a circular array and array queries. For each query, you have to find the minimum distance between. So, 1 second. Okay, draw. I need to find a better tool to, or maybe I need to have a pen or something. But I'm using a MacBook. I don't know what's. Okay, I'll try to search for a better tool because I'm having hard time using my mouse. Okay, what do we have here is a nums array that's circular and an array queries for each query. So this is the query array and an array query. So whatever element, let's say I have an element 8, 11, 12. So for each query, minimum distance between element at this where nums j equals to where nums where the index where nums equals to nums of query bracket I says if no such. Okay, so find the minimum. So next query so let's say I have a nums array that has j element, and so what I want is, so let's say nums at 0, 1, 2 and so forth. So nums bracket j, let's say j is 1. Nums bracket j must be equal to nums bracket j of 1, that should be 1, will be equal. So the value at nums I should be equals to nums bracket query of I, so whatever query of 8. If no such index exists, the answer of that query should be -1. So one thing we can optimize is if, let's say, our query value, the query value is greater than the length of nums. Let's say, what are the constraints? Okay, they've given us the query is less than nums length, so I can skip that thing. Okay, query bracket I is less than. Okay, so return an array answer of the same size as queries where answer I represents. Okay, so what we can do here, so what we need here is, let me create an array list. So we're giving a list back, right? So let's have a list of integer, and are we given query's length is greater than equal to 0. Query dot length is greater than equal to 1. Okay, teacher n equals to queries dot length, or I don't need to have, I can just do a dynamic array. So let's say I have an integer list, I'm gonna name it answer equals to new array list, right? So we have our dynamic list. Now for each query, so what are we doing for integer query in, so for each query I, you have to find for integer query, let me have for integer I in queries, right? What are we doing? The minimum distance between, let me have an integer or minimum distance equals to integer dot max value. So for each query, what am I doing? I need to check if there exists. So for each query, minimum distance between an element at index query I and any other index j in a circular array. So let me have, for each query, let me create another loop for integer j equals to 0. Let me have, because I'm gonna loop through integer n equals to nums dot length, right? And what I want to loop through j must be less than n j plus plus. So for each query, if nums bracket j but then isn't it looping? Well, so let's say if the I should I sort them? Sorting will help or no? Or I need, what do I need? I don't know. I don't want to sort them because same to your answer, right? Let's find the minimum distance between them. So between element and index query I and okay, so what are we doing if no such a return? So we have to find a minimum between the element at index query I. So one of the value is query bracket I, right? So that is I index at query bracket whatever, and any other where nums j. So query bracket 0 is 0 and nums bracket 0, the nearest index with the same value, so the distance between them is 0 1. Okay, query 0 for 0. The same value is 0 1 and 2. I don't get this part. So where nums j nums equals to nums of query 0 is 0, nums j equals to, okay, so I see what's happening. So what we have to check, so for integer j equals to 0, j must be less than we have to do math dot absolute, right? Because we can't else. Okay, so what are we checking? We are checking for integer j equals to, so we are looping through our nums array, and what are we checking? We're checking if nums bracket j, like whatever index, is equal to for minimum distance query I, right? Query bracket 0 equals to each query equals to nums bracket query and then what do we have? It's a circular array, minimum distance between element and any in a circular array. So if it's a circular array, let's say if I found a query, then integer direct equals to if I found nums bracket query, right? If okay, but I need the index for nums bracket query. If okay, this is confusing. Okay, so I'm going through each query. So query is 0, nums bracket 0 is 0 is 1, right? And if I find the next nums bracket 0 if so query is the index value is 1, the nearest. First I have to make sure the value of j in query isn't same, right? Because if it's, for example, here query is 0, which is 0, so 0th index is 1, and for I'm looking through the query if I equals for each query if j plus if nums bracket j equal to so if I do nums array, if nums dot contains if nums okay, I don't need, what if I don't use this loop? Let me remove this, right? If I just do for each query if nums dot contains, so nums is a integer array, it's not a list. Never mind, it's not a list. So if direct equals to so if I find nums bracket j equal to, so for query value nums bracket query j equals to 0, if nums bracket I, automatic nums bracket I, if direct, so right side would be, what is I here? Dot absolute of I minus j, and integer left would be equals to n minus I, n minus direct minimum distance will be equal to math dot minimum of what, minimum distance comma again math dot minimum of direct or left, and then answer dot add and then what are we will add it to our list, right? So answer dot add minimum distance if it exists. But what happens right? So if I, after this, let's say if let me set the minimum distance Windows X integer I plus V. Okay, if I put it in here and then I loop this, once all this loop is done, right, let me remove this. if can I do a ternary operation here? Let me do so dot add what if what the minimum distance equal to integer dot max value, then we do answer dot add -1 else answer dot add minimum distance. Right. And then what is this one here? Sorry, let me move this out 1 second. X. I was putting it in the wrong loop, I think. So should be out here. So we have the minimum distance. Once this whole loop is done, right, once we go through the whole array once, we check if else, right. What am I missing here? Okay, and then there's that. And then we do return answer. Let's try to run this. Let's see where have I. For each query, we compute the minimum distance to max value, right? And then we go through the nums loop. We check if nums j equal to nums bracket integer query. I stays the same. Okay. What have I done wrong here? Let's see, use dictionary that maps each unique value. But is this wrong? Let's try to think. What have I gone wrong? You are comparing the element with its which gives 0, and that this line includes a case where, so yeah. Okay, so our bug was over here. The main issue in your code is subtle, but if you're comparing the element with itself, which gives distance 0. So and becomes, yes, so I need to remove, yeah, you're right. If I is not equal to j, and right, that's all I needed. If I is not equal to if j is not equal, it doesn't matter I or j, but j is changing, right? We were almost correct. Just one thing. Let's try now. Okay, but okay, let's try to think. Okay, the hint they've given here is use dictionary that maps each value in the array to a sorted list of its indices. So use a dictionary that maps each unique value for each query. Use binary search on the sorted indices list to find the nearest occurrence. Okay, so I think right now what's our space-time complexity? Here we are looping once, so O of n plus, we are looping j I times. So our time space complexity here is what? O of I plus O of I times j times j. So q queries n elements, outer loop runs q times n times O of q times n. We don't add them because loops are nested. Okay. Scan. You want the next step. Okay, so if we let me submit it because I don't want to at least submit what we did was right. I'll try to get to this portion where I think what this says is, oh, time limit exceeded, right? Yeah. So it's not, we gotta somehow shorten the case. Okay, let's think about it in this way. So what they've given is use dictionary that maps each unique value to a sorted list of indices. So first, let me reset the code. Okay, so we're given queries, right? If I sort the queries, arrays dot sort queries comma okay. So if we sort the queries first, does that help? Sorting queries won't improve complexity. Even if you do arrays.sort queries, you're still scanning the whole array. Complexity after sorting queries. Sorting only when you can use for each queries you should group indices by value. So each indices by value. So nums example map I is at this index for a query. You look at a position where the value exists. Use binary search to find the nearest index. Okay, so let's try to do this. So first we are mapping the nums. So let me have a map of what I want to have: integer, comma, a list, array list. Sorry, list of what? Integers, right? Let me call it map equals to new. So this thing is C and this be equal to hash map. Yeah, right, equals to new hash map, right? So now what do we want for let me have feature n equals to nums dot length, right? For integer I equals to 0, I must be less than n, and I plus plus. So what are we doing? So what do we need? We need to map the value so for each if let me try it first. If our map dot, I'm gonna use compute if absent, compute if absent what, I'm gonna do what do I need compute if absent of nums bracket I. What am I doing? I'm doing k equals to new array list, right, dot add what, Windows, let me just 1 second. So I'm doing what, map dot compute if absent nums bracket, if the value is not there, compute if absent new array list, right, because we want to create a new array list for everything, dot add I. Is this something we need to do? Let me Windows C 3. It's a function. Oh yeah, equals to, yes I did. Okay, lambda function. Okay, so now I have, so now I, so like, so currently I have mapped every element with its indexes as a list. Now I need to go through each list and sort it. Build the map like, so you are iterating from left. Yeah, oh, okay. So already, yeah, that's correct. So only if inserted, okay. If I scan, they are already sorted. So for each query index, get the list. For each query. Okay, so now what am I doing? For each query is for each integer query in what, queries. What am I doing? I'm doing what do I have? I have the map dot, what do I need? Map So list, I'm gonna get the list of integer called list equals to map dot get value from query, map dot get query, map dot get for each query index I. See, does we from query is an index, not a value, but query is an index. I could do something called nums bracket query. Yes, right, I could do this. Or I could do dot get for each query. So do it on under the same nums loop. Yes, okay. Equals to, instead of query it needs to be nums bracket query, and then now I have the list of. So once I have the list, I need to do binary sorting. So like, let's scalely draw. I have a list of sorted integers like 0, 5, 7 and 8. And how does binary work? Binary work, we have one pointer here, one pointer at the end of the list. Let's say our value is somewhere less than over here 5, right? So we do 0 plus 8 modulus whatever divided by 2, which is equal to 1 plus length of the list, sorry, 1 2 3 4 divided by which is equal to 2. So we check if, okay, binary search was, we have two pointers, these are left and right. But what are we searching here for? Let's think about it. So once we have the list, we have the list of indexes, and for each query value, if nums bracket for each query I, okay, no, I need help with. So currently our list has index positions, and we need to find the smallest distance. How is binary helping, since we have the indexes in order? So for each query index, position of some values, not just index on list, but has elements. Binary, since the list is sorted, binary lets you jump directly to the closest position near I. So in a sorted list, the closest element must be left neighbor, or you can only check two candidates, not all. So if for query binary search finds the position 2 of index, now check left is 4, right is only 2 comparisons, also check wraparound. Yeah. Okay. Oh, so let's see. Okay, now I am having trouble with binary. I know you need 2 pointers left and right at the so okay, let's try to do this. Teacher left equals to 0, right equals to let's dot size, right? Oh, sorry. Teacher right equals to array size -1. So what are we doing? While our left is less than right, check. So this we and the key of your bigger issue now is you wrote correct, but then you started binary search. You're not actually searching. You're not searching for a value, and you're searching for where does the index fit. So you need it works if compare mid value to a target, but your loop correct approach is refresh the size uncertain collections binary search. Okay, now I need okay. So for each query, so this is wrong. Teacher list equals to this. So if list dot size equal to 1, that means search dot add -1, right? And we continue. It only occurs find the position of the queue in the list. So size. Okay, so if the size equal to 1, that means only yeah, if size equals to 1, that means no duplicates exist, right? So if no duplicates exist, what does this do? Okay, means no dupes exist. So check integer position equals to, I don't know what this, collections dot binary search of what, list comma what SQ is for query. Windows C, Windows V. What does this do and return? It searches for value of Q inside the list, inside the sorted list. Case 1, found if Q exists, it returns the index. For example, list is 0 and 2, position is 1. Finds case 2 and returns. Insertion minus insertion point. For example, if Q is 3, it's not in there. Insertion equals to -2 -1 3. So we're doing return. So the query inside the queue. Okay, so what's happening here is once, let me go here, integer size equals to list dot size, right? If, let me remove all of this, if size equals to 1, that's correct, right? And then integer left index equals to position -1 is equal to list dot get what, position -1 comma plus size modulus size multi-position and integer right is equals to list dot get position minus I think. Dot get position plus I modulus size plus 1, sorry, not I. Integer minimum distance equals to integer dot max value, right? And then distance of we have a helper function. We have something called private private int circular distance of pixel and integer n, comma integer right, comma integer left, right, teacher direct to math dot absolute of right minus minus left integer. So we could do return math dot minimum of direct, comma math dot absolute of and minus direct, right, teacher dot max value, right. We're doing minimum distance equals to math dot minimum of min distance, comma of min distance, comma what circular distance, comma circular distance of n, comma q, comma left index, minimum distance equals to math dot min of minimum distance, comma circular distance of n, comma q, comma right index. And then we have answer dot add min distance, right, and we return answer. Where is this error? Here for integer app. Oh, I never created an answer. Let me have a list of what? Integer answer equals to a new array list, right? Cannot find q is in query. Out of bounds, where am I getting the error? Position plus 1 modulus size. How is that out of bounds? Let's try this again. Okay, we learned about binary a little better. Let's see how this guy did it. So from integer from integer to integer from is less than equal to 2, return 2 minus small queries. Okay, if integer okay, never mind. I think it's so much hard to read. Last seen. Okay, I don't know what's going on here. This is way past my level currently. Okay, I'll see you guys tomorrow.